In this lesson, we're going to discuss why we need algebraic methods of solving systems of equations and not just graphical methods for solving systems. And then we'll look at what the concept of substitution is, and then we'll go through the steps of the process for how you carry out the substitution when you're trying to solve a system of equations. So one of the first things I want to address is why can't you just solve every system by graphing? And I think we kind of touched on that in the last lesson. There are plenty of systems where graphing is just not going to be a great method to use. So for example, if you had something like this. Okay, nobody wants to try to graph that. The numbers are both too small and too big at the same time. Okay, and so we don't want to draw any kind of coordinate plane that goes up over 10,000. And even if we did, we'd have to scale it by something like 500s or thousands or something, that we wouldn't have a really accurate graph when we were done with it, because it would just, the numbers would be crammed too close together. If you had a slope like 0.123, that would be 123. There's no and in there. Sorry, if my mom heard me do that, she'd cringe. 123 thousandths. Okay, so if you're trying to graph some kind of line, you're not going to go up 123 and over 1,000. It's just not practical. The other thing that can happen when you're solving systems by graphing is there is no rule that says that where the lines intersect has to be a nice point. So if you look at the two purple lines there and you look at where they intersect, they don't intersect at what we call a lattice point. Okay, they're not intersecting at one of the, well, not like I can put the dots in the right place over there, but I think you get the idea. Like the lattice points, two lines can intersect in the middle of one of the squares. And then what do you do? How do you figure out what that is? And so there's definitely a need for some other strategies for figuring out the values for X and Y. Now, to really emphasize what substitution is, you've been doing substitution from the very beginning of Algebra 1. So for instance, if you had 2x plus 5 and you were given x equals -3, you know that you take the x out of your expression there, and you would put the -3 in its place, okay? And then you would proceed from that point on, working top to bottom to evaluate it. So the idea with substitution is that you take something out. In this case, you take the x out, and you replace or substitute the x with something of equal value to x. In this case, the -3. Okay, so the x comes out and the -3 comes in the x's place. And the reason you're allowed to do that is because they're equal. Now, here's the deal. It doesn't matter if you're substituting in just a number or you're substituting in some kind of expression. So I'm going to do a copy, page, and ink over. And we're going to erase this. I wanted to make sure I retained the last page so it's there, and then I can come over here. All right, and let's say x is equal to, well, let's do two numbers. Now let's do y minus 3, okay? So x is equal to y minus 3. So over here, you would take out the x, and where we had the 3, now we'll do y minus 3, okay? Which of course is going to change the rest of it. So now you're probably wondering, well, why would I want to do that? You probably don't in this case, but you will in a minute. You'll want to do something like that. But the idea is that you take out one thing and you replace that one thing with some other thing that's of equal value. So I always give my students two illustrations. I give them a baking illustration, okay? And we'll use Splenda, okay? Splenda for sugar. So my dad is a diabetic, and my mom has a pumpkin pie recipe that she makes fairly often in the winter, and she tries to make it diabetic friendly. And one of the things that she can do, she doesn't always do it exactly this way, is she can replace the sugar in the pumpkin pie with a sugar substitute that is easier on my dad's blood sugar. Now, in order to do that, she can't just add Splenda to an existing pie. She actually has to take out the existing sugar and then replace it with something of equal value. So Splenda is of equal value, but it's different in a key way. And that difference is that it doesn't spike someone's blood sugar as much. The other illustration that I give is sports, and I usually do specifically baseball, okay? And if you're gonna replace a pitcher, and this is like a pitcher, okay, then you're going to have to take the first pitcher out of the game. You cannot just send a second pitcher out to the pitching mound, okay? If you have two pitchers out there, we have a problem. You can't do that. I know other sports, you're penalized if like the coach sends a replacement or substitute player out onto the field or into the court before the original player is taken out. So you got to take out the original player. And then the person you're replacing them with is of equal value. So you would replace the pitcher with another pitcher. You don't replace the pitcher with a right fielder or a left fielder or a catcher, okay? You place a pitcher with a pitcher, but will be different in some advantageous way. So probably the first pitcher is tired and the second pitcher isn't. Or maybe you're replacing a right-handed pitcher with a left-handed pitcher. Okay, so let's bring this back to the algebra. Suppose you, well, what I'm going to do is put the steps on one side of the screen, and then I'll try to work an example problem on the other side of the screen, and I'll try to color code it, which is something I do for my students all the time. Okay, so on the left-hand side, I have the 5 steps for solving the system through substitution. I've got them color-coded. And then on the right-hand side, we have an example. Now, sometimes those equations will be written one on top of the other, and that's fine too. It can help visually if you write them next to each other. It can just help, okay? So one thing that I would suggest that you do if you struggle with getting a problem like this started is writing the equations side by side. That was actually something that my mom told me worked for her when she taught. So here are the two equations, negative x plus y equals 1 and 2x plus y equals negative 2. And the first step is solve one equation for one variable. So just to make sure that we're interpreting those words correctly, solve one equation for. To solve for means to get by itself. So what that first step is saying, and what you probably want to do, if you're copying this down, pause the video, copying down the steps, you might want to translate that as get one variable all by itself. In other words, when you're done with the first step, you should have either y equals all by itself or an x equals all by itself. And it doesn't matter which one, okay? It doesn't matter which one, if it's going to be x or y, just you have to get one equation solved for one variable. So you do have to make a decision here and decide what variable you're going to try to get by itself. And generally what you're looking for are variables that have a coefficient of 1. Not negative 1, okay, but 1. And looking at these two equations, y in the first equation has a coefficient of 1, and y in the second equation has a coefficient of 1. Either of those would be fine. And so one of the tip-offs for a teacher, because you can choose either one, is if you got 2 people in your class and they choose all the same method every single time. It is possible that that would happen, but it's not very likely, okay? So be careful. It's okay to work with a friend, but make sure that you're trying to do the problems on your own and you're not like coasting on a friend when it comes to doing the problems. Because if you and somebody else are solving like 10 or 12 problems and you make all 10 or 12 decisions exactly the same way, and there's a couple other places where you can make a decision, it's just going to look a little suspicious. So you want to be careful of that. I'm going to, for the sake of just picking one, I'm going to pick this y to get by itself. So in order to get this y by itself, I need to move the negative x out of there. To get the negative x out of there, I could add x. Okay, so I can do plus x and plus x. And of course, negative x plus x is 0, which is what we wanted. And I end up with y equals 1 plus x. And that completes the first step. So solve one equation for one variable. Now, the second step. substitute this expression in for the variable in the other equation. And you have to make sure you go to the other equation. If you substitute it back into itself, you'll end up with what we call a special case. So looking at the other equation, we have a y, and just like I demonstrated over here with the x, okay, you're going to take out one variable and you're going to replace it with something of equal value. Here we took out the x and we replaced the x with y minus 3. Here we are going to take out the y, okay, and we are going to replace the y with something of equal value to y. Well, what's of equal value to y? 1 plus x. And so we're going to have 1 plus x, and that is going to be equal to -2. And it magically fixed itself. It's amazing. Okay, and here's the key advantage. So on this slide over here, we talked about what's the advantage of Splenda over sugar, and it can depend on diabetes, or what's the advantage of one pitcher over another. You might be wondering, well, what's the advantage of 1 plus x over having the y? Well, the advantage is you've gone from an equation that has 2 variables to an equation that just has 1. Now, in this case, those parentheses are what we call cosmetic. They're not actually doing anything. And so when we get to the third step, this is solve for the other variable. So if you chose y in the first step, the other variable is x. So in this case, it's just solve for x. We're going to combine like terms. So 2x plus x is 3x. Subtract 1 from both sides. So 3x equals -3, and divide both sides by 3. So x is equal to -1. Halfway there, okay? And you think like, oh no, not halfway there, but it's okay. So what I did was I copied the steps over onto the next slide and cleared out a little bit more space for us to work. Step 4 says substitute this value into any original equation. And so we've got x equals 1, and we're going to substitute that into either of the original equations. So the original equations were -x plus y equals 1 and 2x plus y equals -2. And you can pick either equation, okay? Either one will work. You could also use your solved equation. So you could use the y equals 1 plus x. In fact, that's often a really good one to use. So let's go ahead and use it. So we're going to take this -1 and we're going to place substitute it in for x right here. And we're going to do that in yellow, I guess. So y equals 1 plus -1. And then the purple step, solve for the second variable. Y is equal to 0. And so our final answer to this problem is x is equal to -1, y is equal to 0, or if you were writing it as an ordered pair, it would be -1, 0. Now, this is also where one of those decision points where you can make a decision about the best way to do it. And if you and your bestie are always making exactly the same decisions, you're always picking the same equation to solve for, and you're always picking the same equation to plug back into, yeah, make sure you're doing the problem on your own first, and then if you want to compare or talk over your solutions with your friends, you can do that. All right, let's work through at least one more example before you are free to do some on your own. Okay, so this one is 2x plus 2y equals 3, and x minus 4y equals -1. And so our first step, solve one equation for one variable. So you kind of go through both of your equations and you look for well, what's the best candidate? Anything that's got a coefficient other than 1 is not a good candidate. And I'm going to quickly show you why. Suppose you picked, x in the first equation, okay? So you're like, I'm going to get the x by itself. And so you subtract 2y from both sides. 2y minus 2y is 0. You get 3 minus 2y. And then you divide by 2. And you end up with that. Now, it does work. It 100% works. If you take this value for x and you plug it in there, you will absolutely get an equation that's going to give you the right answer. But you've got to tangle with this nasty fraction that you have to plug into the other equation. I have had students that insist on doing that, but most normal people are not going to want to do it. It's also another tip off because some of your online apps and stuff will do it that way. So if you're using an app to do your homework, it's a computer, so it just follows whatever the algorithm is. It doesn't make decisions, and so the apps will often take you down very convoluted paths for solving these equations that no human being would ever want to do. You'd be like, that's like a ridiculously hard way to do it. So please don't rely on apps if the problems look a lot harder than whatever your teacher's doing in class. You're probably going the wrong direction with it. You want to do something else. They're amazing. Those apps are amazing, but they do not think. And so they actually will do these problems very, very weird ways sometimes. So looking at these first equations, again, you're looking for something with a coefficient of 1, which would be the x in the second equation. So if I go and do this out, I would be adding 4y to both sides, because negative 4y plus 4y is 0, and I'll get x is equal to negative 1 plus 4y. So that's your first step. And I'm trying to color code this, okay? So that if you're going back to this, you're going back to your notes later, that you'll be able to match like what the verbal description of the step is with what it looks like when it's done out in a problem. Step 2, substitute this expression in for the variable in the other equation. So in the other equation, what we're going to do is take out the x, and we're going to plug in negative 1 plus 4y. And we're allowed to do that because x is equal to negative 1 plus 4y. We're putting in something of equal value. So we're going to have 2, and then we're going to have negative 1 plus 4y plus 2y is equal to 3. And the advantage to doing that is we've gone from an equation that has 2 variables to an equation that just has the y, which means we can do the blue step, which is solve for the other variable. So distributing the 2, we get negative 2 plus 8y. Bring down everything else. 8y plus 2y is 10y. Add 2 to both sides. 10y is equal to 5. Divide both sides by 10. And we're super thrilled to have 1/2. We all wanted that to happen. It's okay though. We've got this. So let's come over here. So we've got y is equal to 1/2, and we're going to substitute that in, and you can really go in any place. I'll do it in a couple different places on this one just so you can see. But we'll substitute it in there. So negative 1 plus 4 times 1/2. 4 times 1/2. I know I've done this before, but that's supposed to be a 4. Okay, that's 4 over 1. You're going to multiply straight across. So 4 times 1 is 4. 1 times 2 is 2. And 4 divided by 2 is 2. And negative 1 plus 2 is 1. And so x is equal to 1. So your final answer, oh, I should have done that in purple. Okay, sorry, I thought I hit the pause button and I did. Okay, so the first one we have y equals x minus 3, 4x plus y equals 32. Second one is 2x minus y equals negative 2, and 4x plus y equals 5. Third is 5x plus 3y equals 11, and x minus 5y equals 5. Fourth is x plus 4y equals 300 and x minus 2y equals 0. And the last one, 3x plus y equals 13 and 2x minus 4y equals 18. All right, so pause the video and work these problems out. Follow the steps, see how you do, and then unpause to check your work. Okay, so here we go for our review. As always with any of the problems, you can pause and study the solution more closely to make sure that you understand. And I really tried to keep the color coding the same as the color coding that I did in the example problems, just to add a little bit of visual help to be able to track the flow of the problems. So for the first one, the first step, the red step, is already done. And one of the tip-offs that I will often see that a student isn't critically thinking about the problems is if they try to rehash a step that's already done. And so in this problem, they might try to get the x by itself by adding 3 to both sides. Now, don't get me wrong, it'll work if you get the x by itself by adding 3 to both sides, but it's creating an extra step. So if you did that, don't mark yourself wrong, don't scribble it out, don't get mad. Just make a little note in the margin that like the first step was already done. And so you did a little bit of extra work and you want to try to avoid that in the future, but it's totally okay if you do it, especially if you understand it. We're not going to sweat the small stuff. Then we're going to plug the x minus 3 in for the y right here. Okay, so instead of plus y. Now, you notice I put those parentheses around it. Those parentheses are, again, what I call cosmetic. They change what the problem looks like, but they don't actually serve an algebraic function. The illustration I always use is your eye makeup, okay? If you put eye makeup on, it will change what your eyes look like, but not what your eyes do. And the reason why a teacher might put the parentheses there is to just make it stand out a little bit more visually so you can see where that substitution happened. But next step, I removed it. You can follow the work here, combining like terms to get the 5x, adding 3, dividing by 5, we get x is 7. Okay, and you can plug it in either place. Okay, you could plug it in right here where I'm hovering and do 4 times 7 is 28 and do 32 minus 28 and get x equals 4. But I don't know why you would do that because you've got a much easier one that you can use. But both should give you the same answer. And so you should have x equals 7, y equals 4 for that first one. Pause if you need to. Okay, next one. I chose the bottom equation and I chose to solve for y. And so that's what we have here. I subtracted 4x from both sides to get y is equal to 5 minus 4x. You could use the y in the top equation, but bear in mind that it is negative. So you would probably add y to both sides and then add 2 to both sides to kind of move it around that way. It will work, but it's creating an extra step. So you didn't make a mistake if you did it that way and plugged it in. You're looking, yeah, I got x equals 1/2 and y equals 3. You probably did. Like you could get it right. But you created an extra step where they didn't need to be one. All right. So now here's where it's easy to make a mistake because these parentheses are not cosmetic. These ones were, and the reason they were was because of the plus sign right there. The plus sign doesn't do anything to the parentheses, but the minus sign right here does. It means whatever your value for y is, you are going to subtract it. So y is equal to 5 minus 4x. You have to make sure that you group those together because you're subtracting the whole group. And so this gets distributed. Minus 5 and then minus negative 4x. Okay, remember subtraction is adding the opposite. So we're going to add the opposite of negative 4x, which is positive 4x. That's probably, if I had to put money on where a lot of people were going to make a mistake in the problem, it would be right about there. 2x plus 4x is 6x. Then we add 5 to both sides. We get 6x is equal to 3. Divide both sides by 6. And 3 over 6 is equal to 1/2. Hopping over here, I picked this equation to plug it into because I could. And it was easy, already solved for it. So we do 4 times 1/2. 4 times 1/2 is 2. 5 minus 2 is 3. Again, okay to make mistakes. That's what practice is about. Just pause the video and kind of scrutinize your work. Look closely at your work. Look at what you did, the order you did it, and where you made the mistake. And then patiently, be patient with yourself and just make those corrections to the work that you're doing so that you don't make the same mistakes over and over again. Next one. I chose the bottom equation, and this time we're solving for x. So I added 5y to both sides and got x equals 5 plus 5y. I actually had to redo this problem because I got answers that didn't check. I just felt like the answers felt wrong. And I'll show you what I did. So now we're going to plug in 5 plus 5y. So we're going to take out the x, and then in place of the x is the 5 plus 5y. Distributing 5 times 5 is 25, 25y, 25y plus 3y is 28y. We subtract 25 from both sides and we get 28y equals negative 14. Divide both sides by 28 and y is equal to negative 1/2. Now I need to take that, and I'm not thrilled, and I'm even less thrilled when I see how this comes out. So I would take the y is equal to negative 1/2. So we have 5 plus 5y becomes 5 plus 5 times negative 1/2. So just so you can follow that scratch work, 5 times negative 1/2 is 5 over 1. And then we multiply straight across to get the negative 5/2. In order to subtract fractions, you do need to have a common denominator. And so I took the 5 and I wrote it as 10 over 2. So you can take a second and see if those are equal, and they are. So we have 10 over 2 minus 5 over 2, which is 5 over 2. The mistake that I made was I dropped the negative right there. And I had y is equal to positive 1/2, which gave me a number that worked for this equation, but did not work when I plugged it in. And it just kind of felt wrong. It just didn't feel like that was the answer I should have gotten. And it wasn't. And I went back and I found my mistake. And it was a common mistake, just like dropping a negative. Like I had the negative written here and just didn't copy it down to the next line. And so, you know, what you would do is the same thing as what I did, is you would go back and just kind of trace your work through and see where that mistake is made. For number, whatever this is, 4, I picked, which one did I pick? I picked the x on the bottom equation, but the x on the top equation would work as well. I added the 2y to both sides to get x equals 2y. And one of the reasons I like that one is because it was the simpler one, rather than having x equals 300 minus 4y, but that also works. So taking this x is equal to 2y and plugging it in here gives us 2y plus 4y equals 300. So 6y equals 300 and y is equal to 50. And then I took the 50 and plugged it in right there. So we have x is equal to 2 times 50, or x is equal to 100. Pause the video if you need to. And the last one, I chose the top equation. Again, you're looking for that variable that has a coefficient of 1. And so I subtracted 3x from both sides to get y equals 13 minus 3x. Then take the second equation, and we're going to take out the y, and we put in 13 minus 3x. Might want to grab a calculator. This gets a little bit big. Negative 4 times 13 is negative 52, and negative 4 times negative 3x is positive 12x. That negative times a negative is going to be a common spot where people make mistakes. 2x plus 12x is 14x. Add 52 to both sides. We get 14x. That 14x equals 70. Divide both sides by 14, and x is equal to 5. And then I took the 5 and plugged it in to my red equation. And so y equals 13 minus 15, or y equals negative 2. So with any of these problems, you might have made all the same decisions as me. These were kind of written so that there was like an obviously best decision. Not every problem is. And then you make sure that you are getting enough practice with this skill, but hopefully this video helped clear up any misconceptions or gave you some tools or some structure to the problems that will help you be a little bit more confident as you try to work your way through them. Now, this strategy does not work well if you don't have a variable that has a coefficient of 1. It does always work. It just doesn't always work really great. And so in the next lesson, we'll explore another strategy for solving systems of equations that works a little bit better, but is going to require you to think.